The final section of Chapter 2 deals with some of the similar things that you did in 2.6 as far as asymptotes are concerned in graphing rational functions. Here we have a couple of examples just to review all of the concepts from section 2.6. This first one here, f of x is x squared minus 9 over x plus 2. And because it is that way, the horizontal asymptote, since the numerator's degree is bigger than the denominator's degree, there is no horizontal one. The vertical asymptotes would be the zeros of the denominator, so if you set that equal to 0 and solve, x would equal negative 2, so we have a vertical asymptote of x equals negative 2. If you factor the numerator, that turns into x plus 3, x minus 3, and there is no factor in the numerator that is also in the denominator, so there is no whole. Then if you want to find the y-intercept, you would substitute 0 into this equation and get negative 9 halves. And then the last thing that you can get from this graph would be the roots or the zeros or the x-intercepts of the function. There, all you have to do is set the numerator equal to 0 and solve it. And we know that that is x plus 3, x minus 3 if you go with the factoring route. And then, so we know x equals a negative 3 and a positive 3. And so then you can sketch the graph of this function. You know that it crosses at positive 3 and negative 3, and 0 and negative 9 halves, which is 4.5, is where it, well, that's a negative 9 halves, so that would be down here below the x-axis, so it looks like that. Now the graph of this, since there is an asymptote at 2, that is right here. And again, that's supposed to be a negative, so that should be over here like so. And now when we draw this, it is going to run like this, and then like this. And then it's going to curve down somewhere in there. And now we will talk about one other thing with this particular problem in a bit. With our other function, 8 x to the fourth minus 9 over x squared minus 16. Horizontal asymptote. Still, there isn't one because the top degree is bigger than the bottom. The vertical asymptote, setting that equal to 0 and solving would get you x equals 4 and x equals negative 4. You can factor it to x plus 4, x minus 4, or take the square root of 16. Either way, you get the same thing. The y-intercept would be, if you substitute 0 in, you would get 0, 9 over 16. And then the roots, or zeros, or x-intercepts, would be setting the numerator equal to 0. And then you can factor it to x squared minus 3 and x squared plus 3. And if you try to factor that, you can't, but if you move the 3 to the other side, you're going to get x squared equals 3. So then x equals plus and minus the square root of 3. And here those would be the square root of 3i because they're imaginary. Now when you draw the graph of this one, you have the asymptotes at the square root of 3 and the square root of a negative 3. And then it looks something like this for a graph. And then this one is up here. And then this one is over here somewhere. And so there is that function. And of course you can put it into your calculator and figure it out from there as well as far as how it looks. Again, there are no holes. when you put it in your calculator, make sure that you group both the numerator and the denominator or you will have the wrong graph. Same with this one. You need to group that and you need to group that with a division sign in between. Now, as I said, this one here, it only has a vertical asymptote and not a horizontal. Same with this one, but this one here has some other type of asymptote, because if you look at this graph, it kind of runs along here and it runs there. So there is an asymptote that is going to be right in there. And we can find that. That asymptote is called a slant asymptote because it's at an angle. It's slanted. It is a line, just like the other asymptotes. To find it, or first off, the first thing you need to understand about the slant asymptote, it can only happen or occur if there is no horizontal asymptote. And the degree of the numerator is 1 more than the denominator. So because this is 2, and this degree is 1, that's 1 more than that. So now we have a slant asymptote. Over here with this one, there is no horizontal. But because that is 2 more than this, there is no slant either. So then how do we find the slant? All you have to do is divide them. And the quotient will be the equation of the line for the slant asymptote. Now, if you can try to divide it synthetically. If you don't recall the synthetic way, then you do it the long method and put x plus 2. And then here you would have x squared, leave a space, and minus 9. And now we figure out what times x gets us x squared, and that would be x. So we get x squared plus 2x. Draw our line and end up subtracting. And x squared minus x squared is 0. 0 minus 2x is a negative 2x, and we bring down the negative 9. Now we figure out what times x gets us negative 2x, and that would be a negative 2. When we multiply then, negative 2 times x is a negative 2x, and a negative 2 times 2 is a negative 4. Draw our line, and again we have to subtract. Negative 2x minus negative 2x is 0, and a negative 9 minus a negative 4 is a negative 5. The remainder is not significant in this particular problem. All we need is that. That equation, y equals x minus 2, is our slant asymptote. And so then we know from our graph then that this is a pretty crappy drawing. It should be up here. Actually, no, it should not be up there. It should be the other way. Having issues today. So it should be like that. And so there's our vertical asymptote. There's our slant. And that is how you find a slant asymptote. All you need to do is divide the two things. And like I said, if you have some linear function in the denominator, then you can do it synthetically and put your negative 2 out here and do 1, 0, and negative 9 and go through the whole process, and you'll still get the same answer. That concludes section 2.7 notes.